In this video, we will look at the formulas for lowering powers. So the following formulas will allow us to write any trigonometric expression involving even powers of sine and cosine in terms of the first power of cosine only. This technique is important in calculus, so a lot of these things that we're developing right now are preparing you for your next steps into the world of calculus. We'll do a quick review of our formulas that we've learned so far. I'll do a single proof of the formulas for lowering powers, and you can do the others on your own if you would like. I'll give you the list of formulas, and then we will look at a quick example. So first, here are your double angle formulas. I'm not going to read them all, but just a quick refresher. Remember, we can derive these from the addition and subtraction formulas for sine and cosine. Specifically, we derive these from the addition formulas for sine and cosine, but it is important to know well the addition and subtraction formulas for sine and cosine. So now, write sine squared in terms of the first power of cosine. So when I think about this, and I'm thinking about, okay, well, what formulas do we have that has both sine squared and the first power of cosine? I'm thinking about the double angle formula for cosine. Remember, that is cosine 2x. And kind of in its standard form, if you will, that's cosine squared x minus sine squared x. Then if we want to substitute something in so we can write the double angle formula for cosine in terms of just sine or cosine, we can use our Pythagorean identity to do so. In particular, we're looking at trying to write sine squared of x in terms of the first power of cosine. So that's making me think we need to substitute in 1 minus sine squared x. So we can simplify down to 1 minus 2 sine squared x. Now we need to isolate sine squared x. So if we take cosine 2x, if we swap the cosine 2x and the 2 sine squared x, we have 2 sine squared x equals 1 minus cosine 2x. And then if we just divide over by 2, we have sine squared x equals 1 minus cosine 2x over 2. Just a little bit of algebra, but it gives us a new formula that we can use and look for when we're proving identities, when we're trying to solve particular kinds of problems. And we have other relevant and similarly derived formulas like these. These are called the formulas for lowering powers. And you can kind of see why they're called formulas for lowering powers. We start with a sine squared and we end up with a cosine to the first of 2x, and similarly cosine squared end up with cosine to the first. So we know the sine squared x equals 1 minus cosine 2x over 2. Cosine squared x equals 1 plus cosine 2x over 2. And then tangent squared x, since that's just sine squared x over cosine squared x, that gives us 1 minus cosine 2x over 1 plus cosine 2x. So now, express sine squared x, cosine squared x in terms of the first power of cosine. So sine squared x, we know sine squared x, that equals 1 minus cosine 2x over 2, and cosine squared x equals 1 plus cosine 2x over 2. So if we're trying to get sine squared x times cosine squared x, we can say sine squared x cosine squared x equals, parentheses, 1 minus cosine 2x over 2 times 1 plus cosine 2x over 2. So now this equals, since this is a factored form of a difference of squares, this gives us 1 squared, which is 1, minus cosine squared 2x over 4. So this we can simplify to 1/4 minus 1/4 cosine squared 2x. Now there's a particular reason why I want us to do this, because cosine squared 2x, if we kind of cover up the 2, that makes me think of this formula here. And maybe there's a way that we can write it So we have cosine squared 2x, and we have an equivalent formula for that. So if we have cosine squared 2x, if we notice that in our cosine squared power lowering formula, we start with an x, and in its equivalent formula, we have a 2x. So we can write cosine squared 2x as 1 plus cosine 4x over 2. So now we can substitute in, switch back to the blue color. So we have 1/4 minus 1/4 times 1 plus cosine 4x over 2, which we can just keep on simplifying. That gives us 1/4 minus 1/8 minus cosine 4x over 8. So we have 1/8 minus cosine 4x over 8, or in other words, 1/8 times 1 minus cosine 4x. So this equals sine squared x times cosine squared x in terms of the first power of cosine. So if we're a little bit clever, we can actually get pretty far with a lot of our identities. We can rewrite them in a number of different ways to make the problem solving a lot easier. And this is a really important technique to be developing for when we start solving equations with various trigonometric expressions. In the next video, we will use this knowledge to develop the half angle formulas for sine, cosine, and tangent.